we're going to start with graphing exponential functions, and I've actually filled in one table for you, and I want to just show you what the process was. Look, I took the equation, 3 times 2 to the power of x. Look, 3 times 2. Look here, x was negative 2 to the power of negative 2. Just put it in my calculator. 3 times 2 to the power of negative 2. 0.75. Now look, this is math I can do, right? This is 3 times 2 to the negative 2 is 1 over 2 to the 2, which is 4, right? This is 3/4, which is the same as 0.75. This is all math I can do, but I'm not going to. I'm just lazy, right? This was 3 times 1 over 2. Look, 2 to the 0 power was 1. This is 3 times 1. Look, this is 3 times 2. This became 3 times 4 and 3 times 8. So you can kind of see where this came from, okay? But I'm going to model it down below, but right now I'm just going to graph. Look, this point is negative 2, 0.75. So I'm going to go to negative 2 on the x-axis. 0.75 is just below 1. Okay, negative 1, 1.5. Negative 1, 1.5 is right here. 0, 3. So I'm going to go to 0 on the x-axis. Here's 3. 1, 6. Here's 1, 6. 2, 12. And 3, 24. Oh, look, it goes off my graph. So like I can eyeball it. Like, it's like somewhere right, maybe right there. But then you're going to go ahead and just do your best to kind of draw this curve. We know what it looks like. We knew just from looking at the equation that the graph was going to have this shape, this exponential growth shape, right? And it continues forever up that way. Let's do another one. Okay. This is 3 times 1/2 to the power of negative 2. I'm going to do the whole thing in my calculator. Look, 3 times 1/2 is 1 divided by 2 to the power of, that's this button, to the power of negative 2. 12, okay? Now look, that makes sense. Look, this 1/2 to the negative 2, look, the negative flips it over, and then it's 2 to the power of 2. That's 4. This is 3 times 4, okay? This is 3 times 1/2 to the power of negative 1. This is going to be, look, this is equal to 2. This is going to be 3 times 2. Look, but you don't have to know that. Look, watch what I'm going to do. Watch how lazy I am. I already have 3 times 1/2 to the power of, watch. Oh, the laziest. There it is. Look. Now here's what's wild, right? You can keep going. I can keep plugging this in my calculator. Look, to the power of 0. Even though I know 1/2 to the power of 0 is 1. This is 3 times 1. Look, I can come here. I can do it. Look, I'm going to delete and put 0 and get 3, right? 3 times 1. I knew that was 3. But guys, look. Look at the pattern. I'm multiplying by 1/2. So what's happening? I'm dividing by 2. I'm dividing by 2. Look, I'm going to divide by 2 right now. This is 3 times 1/2 to the power of 1. Look, what's 3 divided by 2? Now look, you could do it here. But 3 divided by 2 is just 1.5, right? Look, put to the power of 1. 1.5. When I make it to the power of 2, look, come back to your calculator. Power of 2, 0.75. Power of 3, dividing by 2, 0.375. Okay, that was this. All right, let's graph it. Negative 2, 12. Negative 1, 6. We know what the shape is going to be, right? We knew as soon as we saw the equation, oh, that's exponential decay. That's going to be that curve down. 1, 1.5. 2, 0.75. And 3, look, we're getting closer and closer to 0, right? We're going to keep dividing by 2 over and over and over. It's going to keep getting smaller. Now, it never quite gets to 0, right? But it gets smaller and smaller and smaller and gets closer to 0. All right, looks like that. Okay, you're going to go ahead and try over here. And again, once you put it in your calculator, look, once you put 5 times 2 to the power of in your calculator, then you're just going to type negative 2, right? Press enter, and then you're going to come back here, type negative 1. Don't retype it every time. Be lazy, okay?